here's a rule that you need. Hopefully you guys saw the video ahead of time, and if not, it's cool. Try my best to catch you up. So for the chain rule, if you have some function, let's call it, let's see here. Let's say that y is equal to some function composed with g, right? That looks ugly. So g is inside f, and you want to take the derivative of y. So the rule says, suppose f and g are differentiable y prime will then be equal to, or if you prefer, dy dx, right? That will be equal to the derivative of the outside function. You leave the inside alone, times the derivative of the inside. So if you have this composed with multiple functions, like multiple pieces, you'll just tack on multiple derivatives. So let's say there was a function within a function within a function, you'll just multiply times the inner, the innermost, and etc. So you're done. Okay. So let me show you a quick example here. So example one basically starts out trying to get you to see what is the inner function. Let's see here. So all you need is this and some practice, and it should make sense. So given y equal to f of g part A, find g. And f. So basically tell me what the inner and outers are going to be. So here is y. 3x minus 7 squared. 3x minus 7, the whole thing squared. So do you see what the inner function is going to be?
3x minus 7.
Yeah, so the inner one, g, is the 3x minus 7. What is the outer function?
Square.
Yeah, the square, so it's just something squared. Okay, some function u, whatever. So all they're going to want you to do is label what is what. In the notes, actually, they call this u. So let me just double check my notation. Not that it matters, but yeah, it's going to bug me. Hold on 1 second. Yeah, just wait on this for a second. So in the book, in the homework, they call this u right here. So f of u is going to equal to u squared. So I'm skipping a step there. So long as you can identify it, the formula will be very, very straightforward. Shouldn't be too bad. Okay, let's see here. Let's do an actual problem. number 5. So this is number 5. Find the derivative. So 1 through 4 is just trying to identify what's inside, what's outside. That's it. So 5, we actually start using the formula. I'm going to relabel it as y is equal to 2 times 5 minus 7x to the 5th. Okay. So the outer function is the 5th, right? The inner is a 5 minus 7x. So the derivative will be, you take the derivative of the outside, so that's a power rule. So you bring down the 5. You do nothing with the inside, and you subtract 1. Then you multiply by the derivative of the inside. That's what this formula is saying here. Does that make sense? So this would be 10, 5 minus 7x to the 4th times that derivative. That derivative will be -7. You guys agree with that? Do you see how this is the f prime and the g prime from this formula up here? Is that clear? So let's do a bunch of these because the entire section is just this over and over again. Trying to get comfortable with the chain because the chain rule is very important and it can come up in many different forms.
As far as go with that one. Is that 10?
Well, technically we can multiply that, right?
Yeah.
-70 times 5 minus 7x to the 4th. Yeah, we should go one more step. All right, let's go ahead and move to the next problem. Find the derivative. So y is equal to 9x plus 4 to the 2/3. They use t in the homework, but I don't like t. And I changed it to the y instead of f. Who cares? So the derivative, right? We do the outside first. So you bring down the 2/3. You don't mess with the inside. Subtract 1 times the derivative of the inside. Which will be 2/3 times 9x plus 4. 2/3 minus 1 is a -3rd times the derivative of 9x plus 4 is a 9, right? So 9 times 2/3, that's going to be 6. So our answer will be 6 over, I'm going to space here, 9x plus 4 to the 1/3. Got to bring the negative 1/3 to the bottom. Is that okay? Should be a fraction. Any questions on number 3? Okay. Let's do problem 8. This is 4 or 3? Find the derivative of y equal to cube root of 6x squared plus 7. So the outer is the cube root. The inner is at 6x squared plus 7, right? So the derivative will be, well, first let's actually rewrite the question. So it's more obvious. Be 6x squared plus 7 to the 1/3. The derivative will be, so you take the derivative of the outside. Subtract 1, and then multiply by the derivative of the inside. So that will be 1/3 times 6x squared plus 7. 1/3 minus 1 is a negative 2/3, right? Derivative of this guy is 12x. Okay. So at this point, we're just going to do some algebra to make it pretty. So we got 12x on top. I'm going to bring down this to the bottom because it has a negative power on it. 6x squared plus 7 to the 2/3. Any question on this so far? So 12 divided by 3 is a final step here. Nothing else to do. So sometimes when you're doing the quotient or the chain rule, a quotient or a product rule will show up during the process. So nothing's gonna change as far as the rules. It's just, it's gonna be uglier. That's it, more work. Let's do one that's has a product. Problem 11 looks like a good one. So y is equal to x squared times the square root of 9 minus x squared. So on this one, as you're doing the product, you're going to have to do a chain. So the derivative is going to be x squared times the derivative of the second term plus the derivative of the first term times the second term. This is going to have to be a 1/2 before we do it. Make it a bracket, I guess. Get rid of that. Plus, I'll do the derivatives in the next step, not this step. Okay. The derivative of this is going to be a chain rule. So bring down the, let's go ahead and do it here. 1/2 times 9 minus x squared to the 1/2 minus 1 times the derivative of the inside. Plus derivative of x squared is 2x times 9 minus x squared to the 1/2. So it's getting a little ugly. So this will be 1/2 times 9 minus x squared to the -1/2 times derivative of this guy will be -2x plus 2x times 9 minus x squared. So all the derivatives are done. Product rule is done. Chain rule is done. So now we just got to do some algebra. So I can see that the 1/2 and the 2 are going to cancel, right? Negative will make the whole thing negative. So the answer is going to be for the first piece. This will go on the bottom because it has a negative power. So we're going to end up with negative x cubed over 9 minus x squared to the 1/2 plus 2x times 9 minus x squared. Now we could combine the fractions. That's the only step left. Our denominator is, our LCD is 9 minus x squared to the half. So introduce that over here and combine them together. I'm gonna need another page for that. Now wait a second.
Where did you get the x cubed?
Oh, x squared times x can be cubed. Because they're all times, right?
Yeah, so you did x cubed times 1/2, and then that's what made it a fraction, right?
The half and the 2 canceled. Right, 2 times a half is 1. So that was gone. The negative is in front. The x squared times x is x cubed. This is on the bottom because it had a negative power. So that just came down.
So like that 9 minus x squared, like that really didn't even like count for anything. Like you didn't multiply the x squared by that. It just went down to the bottom. And then the half and the negative 2x were just multiplied by the x squared.
Yeah, all of them, everything here are being multiplied. But I didn't actually do anything with this, like you said. I just brought it to the bottom. But they are all in fact products. There's a times between every single piece here. Let's skip some algebra, a little bit of algebra because I ran out of space. But do you see it?
Yeah, it's just a lot. It's a lot of algebra and doing it in like little sections.
Yeah.
Becomes complicated very quickly.
Yeah, I think that's gonna be the hardest. I mean, the hardest part of the thing of this class is keeping your algebra straight. At this point, there's not much theory. It's just applying these rules. Okay, let's do the next part here. Let's continue this problem. Continue this problem on the next page. You want to multiply the top and bottom by this denominator for the second piece here. And just pretend there's a giant 1 underneath. Okay, I didn't change the first part. Still the same. So this will give us a 2x times, so 1/2 times the same base. You add the powers, it gives you a whole. 2 halves make a 1, right? The bottom now has the same LCD. So you can add the fractions. So we're going to have negative . We have negative x squared. Oh, is it cubed? Oh, I changed it by accident. My bad. 2x times 9 minus x squared over, technically this is a square root. I'm just going to change it because it's easier to write. Distribute the top part will give us 18x minus 2x cubed. Again, I'm just doing algebra at this point. The calculus ended a long time ago. This is a negative 3x cubed plus 18x over 9 minus x squared. Not much to do anymore. Let's go ahead and finish it here. You can factor a negative 3. That's about it. Now, actually, and an x. But I think that's enough personally, but I think the homework factored a 3x for fun.
Doesn't cancel at all.
Nah.
Why didn't you bring back the square root again? You said it was just for to show. I don't know where the shit is for.
Oh, it's a half power the whole time. So the whole time it is a square root.
Yeah.
I just decided to write it this way just because it's a little faster to write the symbol of root. So that will be x squared minus what? Six, right? There, I got paranoid. I mean, I think this last one's good enough, but you could factor that if you want. Anyway, any questions on any of this algebra? There's a lot of it. So you can see how they get kind of out of hand when you have chain rules, because products or quotients or whatever will pop up at the same time.
So the derivative of square root is 1/2, right? It would be like, because like here obviously it's like 9 minus x squared is to the 1/2.
Mhm.
And the 1/2 doesn't go in the front, or is the 1/2 that goes in the front at 2x?
The 1/2 means square root.
Right. So that would just be like if you were just doing a straight square root, that would just be it, right? Like if you find the derivative.
Yeah, the square root's on both of these terms. The 1/2 on both.
It's on both sides.
Are you asking what the derivative would be of that piece, or I'm sorry?
Yeah, I was just kind of confused because like when you switched it back, I
Mhm.
like how I know it is that like the derivative of square root is like I thought was like 1/2 9 minus x squared up to the -1.
Yeah, I mean, that would be true, but I didn't do any, I'm not doing any derivatives on this page.
Oh, okay. Oh, so it's just equal.
All this is just algebra. I'm just combining fractions,
Oh, yeah.
rewriting the problem. But if you were to do a derivative, yeah, you would be right. Yeah. If that was its own separate thing, sure. You
But
bring the
it's
half
just the
down.
algebra, it just equals that and you made it so it's easier to write faster.
Yeah, there was no reason as to why I switched from 1/2 power to square root symbol. That was just personal preference. It wasn't an algebra step, really.
On the previous page, I'm still trying to understand how you pretty much after the third line on the fourth line, I'm trying to figure out how you got to that point. Yeah,
Here?
I'm trying to figure out how that occurred, all of that.
From here to here?
No, from 3 to 4.
Oh, 3 to 4. Okay, so alrighty. All right, so see how there's a quote on here, right? We need to
Yeah.
get rid of this guy.
Yes.
So you take the 1/2 down. So we did here. And then you subtract by 1. then the chain rule says you multiply by the derivative of the inside. So that's where this whole thing came from. That's the chain rule for this derivative right here.
Oh, okay.
And then we did the derivative of this one, which is 2x. And this was, I didn't do anything to this. So from 3 to 4, I was taking care of everything that had the quotes, taking those derivatives. And that's where this came from. And then I have to do this derivative right here.
Oh, okay. That makes sense.
Okay. Any other questions? Yeah, it's very algebra heavy. Let's do something even more annoying. Let's do one that has a quotient. Oh, this one looks really shitty. Let's do this one. Example. 5, right? Um, 13 looks disturbing. Okay, so I'm gonna use x instead of t. So h of x equal to x cubed over x to the 6 plus 7 squared.
So this one you just do chain and quotient?
Yeah, so during the chain, you'll have to do a quotient.
So you do chain first and then quotient?
Yeah, because the chain you're forced to do the chain because there's an inner part and an outer part, right?
Yeah.
So let's show the steps, right? The chain is going first technically. So you do derivative outside, you bring down the 2. Two minus 1. Then you have to do multiply by the you have to multiply by the derivative of the inside, which is a quotient.
Oh, I see. So I guess that makes it super long, right? The second part.
Yeah, so it's like we have a multi-step problem almost. Okay, where is it? Yeah, there it is. So this part's pretty much done. 2 minus 1, that's going to be gone. The power's gone at that point, right? So you can just say this is 2x cubed over x to the 6 plus 7. Let's deal with this thing. So I'm going to ignore this for a while and work inside here. So the quotient rule says, do you take the derivative of the top times the bottom? All right, I'm going to use the notation, not actually do it just yet. Minus the derivative of the bottom times the top. Everything over the bottom squared. Okay, so this derivative right here is being done with a quotient rule, which is the formula I gave you last time. Okay. So first step was the chain. The second step was the beginning of the quotient. So now let's actually do the derivatives. Okay, so derivative of x cubed is 3x squared times this nonsense. Derivative of this guy will be 6x to the 5th times this. So the derivatives are now done. Now we just have to do some algebra. Calculus step has finished. Okay. Technically, these are being multiplied, right? So it'd be 1 times 2 of these, which would be 3. No big deal. So we have 2x cubed over x to the 6 plus 7 cubed. Times. So let's simplify all this stuff on top. That will be 3x to the 8. 3x squared times 7 will be 21x squared minus 6x to the 5th times x cubed will be 6x to the 8th. Alrighty. Now I have to distribute 2x cubed on all of these terms. Okay. Let me write that a little prettier. I just want to put this on the bottom. Doesn't really matter. It's an unnecessary step. But it looks prettier, right? No? I don't know. All right, so just distribute the 2x cubed and you're done. Let me look at the answer. Okay, whatever. So that'll be 6x to the, well, actually, what we could do is factor instead. Instead of multiplying it in, let's just take out what's in common. What do they all have in common right here? 3 and looks like x squared, right? So I'm going to pull out a 3x squared. So that will leave me with x to the 6 plus 7 minus 2x to the 6. I probably should have combined those two terms. I forgot. I notice these are the same, the 8 and 8. I just forgot about it. Doesn't make a difference. It's just should have combined the like terms. So these two will become 6x to the 5th times 7 minus x to the 6 over x to the 6 plus 7 cubed. That's as pretty as it's going to get. Any questions on any of the algebra steps?
So that was basically the quotient rule first and then the chain rule.
Yeah, it started with the chain rule here, which then created a quotient.
Oh, okay.
So for that 3x to the 8, how did you get 3x squared again? And it's like third from the bottom up.
How did I do it? Sorry.
So you got 3x 8 to the 8 plus 21x squared minus 6x to the 8.
Uh-huh.
How did you get that to 3x squared?
So they all had a 3x squared in common. So I factored it out. Right, so if you factor on x squared, they all reduce by 2, right? And I pulled out the 3, so this became 1, 7, 2.
Is there another way to do that other than factoring? Like if you had like just tried doing the, like if you didn't factor and you just did another way of doing it, like straight bare hands.
Like multiply it in, or what do you mean?
Yeah, like the 2x there, well, I guess there's really not a lot you could do after that other than factor.
Yeah, there's not much you can do other than expand all the terms out or factor them and simplify and into more of a simplified form. It's either or. You either keep it factored and neat or have a ton of terms everywhere. I wouldn't want to multiply this 3 times personally, but you could. The homework actually left it. Yeah, the homework answer looks freaking weird. I like this better. Okay. Let's do some trig types that have chain rules, trig type problems. Let's do something simple first. Find the derivative. This is problem 17. So y is equal to cosine of 3x. So y prime will be the derivative of the outside. What is the derivative of cosine? So you don't mess with the inside just like before. Then you multiply by the derivative of the inside. So it's the same deal. It's just the functions are different. Derivative of 3x would be 3. So the answer would be 3 sine of 3x. Is that straightforward? Let's do this a little more complicated. This one's similar to 20, but I'm going to change it. So y is equal to 3 cosine of 5x, everything squared. You see how that's three functions, right? A function within a function within a function. So the outer is a square. The next inner is the cosine, and the innermost is 5x. So the derivative will have three pieces to this chain, I guess. So 3. So derivative of the outside, don't mess with the inside, times the derivative of the inside, right? Show extra steps because we have three pieces here. So that'd be cosine of 5x to the first times what's the derivative of cosine 5x? All right.
The negative sign.
Yeah. Gonna be-
5x, right?
Yes, that's right. And then times the derivative inside of that. So this will be -6 cosine 5x sine 5x. Derivative of 5x will be 5. So I went ahead and multiply the negative and the 6 here. And I combine the cosine and sine, or I put them next to each other. Just be a little neater. So -6 times the 5 is the final step. So we get -30 cosine of 5x times sine of 5x. Any question about this problem?
No question about the problem in particular, but I'm trying to remember off of pre-cal, unless I'm remembering it wrong, isn't there some sort of abbreviation or rule when cosine is multiplying with sine? Or am I thinking of
Yeah,
something
they're
else?
talking about identity, right?
Yes.
Yeah, I think it's a double angle of cosine 2 theta. Let me double check that. One sec.
Because I think isn't it like cosine squared plus sine squared equals 1 or something? Or
Yeah, that's the original. Then you derive the rest with that guy. So what you could do, I mean, you don't have to, but you could combine this into the double angle. Because sine 2 theta is equal to 2 sine cosine. So like,
oh yeah.
so you could change this guy into, let me see, 15 sine of 10x. Technically, you could.
Okay, yeah. I was just making sure my memory was serving me right and I wasn't going crazy. I'm like, I know for a fact that there's like a double
Yeah.
angle or something.
Yeah, you're right. This is
Okay.
double angle identity. Although you don't have to do that. You can stop here and the computer should take it. But if you want to be, if you want a little bit prettier, you could. Go one more step.
Okay. Sweet. Thank you, sir.
Okay. That's pretty much it for chain rule. Is it making sense? Is it all right? So it starts off pretty slow, but you can see that as the functions get weird or complicated, so does the algebra. So it all depends on the function and how many compositions you have. This one had three total, or two inner functions, if you prefer. You guys have any homework problems you want to go over, or any concerns or issues? I think I'm going to stop here as far as the lecture. Maybe you guys can bring some chain rule questions next time as well. Okay, I'm gonna try to have your exams ready by this weekend. Is my goal. Also, we're getting close to the end of chapter 3, I think. Let me check.